Okay. Other questions before we get going? Last chance. All right, so where are we? So we're sitting here. Whoa, what? Weird. Wait, I'm confused. Why is my calendar like this? Weird. Okay. So it's the 19th. We have 1, 2, 3 weeks left, right, of the semester? It's about a quarter of the semester left. All right, perfect. Oh, you can't see anything. My goodness. Why can't you see anything? Because I'm not plugged in. That's why. See if that helps. Probably will. No input detected, really. There we go. Okay. You can see this at the back, eh? Or is it too bright with the windows open? No? You're good? All righty. So where we left off. So we had this sphere, and you know what? Let's go and recreate the sphere. Let's just make sure we're taking our time. So we've got our sphere object, and if you have a question at any point along the way, ask now. Like everything in the course, I'm starting to think people weren't asking questions when they should have been, by the way. So ask when you have a question. So let's start adding to the sphere class. Okay, so there's our, what do we call this method? Who can yell it out fastest? The constructor. Sometimes referred to as the initializer in Python, which is technically correct, but we're just going to call it the constructor. And it's the super special method that gets called to do all the setup for the object we're creating. And when you look at this, here's a quick test. How many attributes does this class have? Give it a second, and then on the count of 3, everyone's going to shout it out. 1, 2, 3. 4. Good job, everyone. Okay, so we're going to add a few methods here. And remember, the attributes, they're just variables. They're data. We added 3 methods here. These methods might get confused with data because they really do just return like a value, but there's some functionality. These things actually need to get calculated. So it goes and calculates the diameter based on the radius and so on. But then we started adding some more interesting methods. I don't know, maybe more interesting isn't the right way to word it, but I think they're more interesting. Like this method here. And the reason I felt this one was a little more interesting was because it's a method that receives as a parameter another sphere. And then based on if I'm a sphere and someone tells me to calculate the distance between centers, I take my x and their x and calculate their difference and square it and add up to the my y and their, and so on and so on and so on. So myself and the other, right? So this one takes a reference to another sphere. And then we added 2 more methods here, distance between centers. Oh wait, no, that's the same one we just did. Here we go. Distance between edges. Which, of course, we couldn't go reinvent everything from the ground up, but we already have a method called distance between centers. And if I know the distance between centers, I could calculate the distance between the edges by just taking the distance between centers and minus each of their radiuses. Cool. And then the last method we added was overlaps. And remember, we had a little bit of a discussion around overlaps. overlaps, should it have been strictly less than? I don't know. But this is what I did. I did less than or equal to. So what do we do? Well, this overlaps method actually just calls the distance between edges. And if the distance between the edges is less than or equal to 0, we are concluding that these two spheres overlap. It returns the Boolean. That is the result of the question. Is the distance between edges less than or equal to 0? And remember, we had a little conversation around, should it really just be less than or equal to? I don't know. It's up to whoever. For my purposes, maybe I say, if they're touching, they're overlapping. Even though you might say, like, if they're touching, they're not overlapping, they're just touching. Yeah, sure, fair enough. But that's up to you. Any questions about any of this? Yes? Yeah. So if their distance was 0. So if you were to say, like, no, I don't like this. I want it to be like there. That would mean they are actually overlapping. If it is equal to 0, that means they're touching. And if someone were to say to me, they're not overlapping, they're touching, I'd have to concede, yeah, you got a good point there. But this is like an edge case, whatever. Other questions? This right here is an example of a design decision, and maybe for my needs, for all intents and purposes, if they're touching, they're overlapping for what I need. Happy, sad, what do we think? So at this stage, this is still a relatively simple object. The object that we defined, or pardon me, the class we defined before was the circle. And the circle only had the radius. What we've done here is we added 3 more attributes, a point in 3-dimensional space, x, y, z. And we added methods that were a little more interesting, I think. It enabled us to have, like, using information from one object and another object, they can interact in some way. So now we have objects interacting with one another. That's what these methods were enabling. Cool? Now, Python and other programming languages have the same idea, but Python has a suite of special methods they'll call magic methods. Sometimes they call them dunder methods for like double underscore. I hate when people say that. I call them magic methods. Now, init is one of them. It's a special method with a special name that has special meaning under certain circumstances, okay? It's the constructor. I don't call init explicitly, and by the way, you never call these magic methods directly. At no point did I call the method underscore underscore init underscore underscore explicitly. I never explicitly wrote that. I effectively do call it when I say when I call this print my, this isn't going to do very much. It's just going to print out the memory address of where the sphere is, but it shows you that it does in fact exist. When I called sphere, like the right-hand side of line 1 there, the name of the class, to create the instance, it calls init. And like I showed you previously, I'll show you again here, to convince ourselves that this method actually did run when we did that, no, I ran. And when we run this again and we call this, we can see it prints out I ran, meaning it did in fact run. Okay? So even though I never called underscore underscore init underscore underscore directly, it still gets called. There's a variety of other methods like this that we don't call directly, but we can invoke in other ways. Did you have a question? No, okay. I got excited. I thought maybe you did. All right, so let's start talking about some of these magic methods. A lot of these magic methods kind of exist. So there are some magic methods you almost always want to implement. Some you only, and then like there's a bunch that you only implement if you need to. Like there's no sense implementing it, it doesn't really matter. But some like you almost always want to implement. The first one we're going to talk about is underscore underscore EQ underscore underscore. And this is a special method that lets us define what it means for two, in this case, if I'm writing it inside the sphere class, this allows me to define what it means for two spheres to be equal. Okay? So it's common to want to check if two things are equal. Obviously, like for example, if some number is 10, do something. Like obviously this is handy. And I could check equality with equals equals. Python already knows how to check equality for the types that it lets you use for free. But we are defining a new type right now. We're defining a class sphere. It creates a whole new type. So Python's too dumb to know what it means for spheres to be equal. So we have to tell Python, this is what it means for spheres to be equal. We get to define it. Yeah, did you have a question?
You just answered it.
Oh, okay. So we get to define it. Now, obviously, we want to define it in a way that makes sense for our needs. What does it mean for two spheres to be equal? Well, that's actually not a trivial thing to answer. Should they be equal if they have the same radius, but I don't care if they're in the same physical like three-dimensional spot? Is that fair? Maybe for my needs, that makes perfect sense. They're the same sphere. Sure, they're in different locations, but they are deemed equivalent. Or maybe for my needs, they both need to have the same radius, but they must also exist in the same three-dimensional location. Maybe for my needs, that makes sense. It's up to us. What makes sense for me might not make sense for you in your context. We get to define it. When we are programming these things, we are God. In our own universe, that is our program. We define what it means. If you want two spheres to be equal, if it's 12 p.m., fine. You can. That's stupid, but you could. You could do whatever you want. Okay, by the way, this equals method, if you don't write it, Python sneaks one in there for you for free. And the free equals, I already showed it to you. The free equals is that sameness thing. I showed it to you last time or maybe the time before. Python's equals that it gives you for free is check if you have like effectively aliases to the same instance. Then it's true. That's the one you get for free. So, a more reasonable equality check for us, for our sphere, would be to check if they're the same size and exist in the same location. But like I just said, maybe for your needs, they don't need to exist in the same location. That's fine. It's up to you. It really depends on what you need. So here's how I'm going to define my equality. First, the function definition is going to be def underscore underscore EQ underscore underscore, and it always starts with a self, and then the second parameter. Now, we don't need to call it other. I call it other here. This method must have one parameter. I mean, two. It needs self, but that's kind of a given. And then the other, the thing I'm comparing myself to. All right? And what do I want to check? Well, if self equal and other equal are equal, and the y's are equal, and the z's are equal, and the radius are equal, then it's true. Only if all of that is true, we return true. Once I define that, let's make like 1, 2, 3, 4. A, B equal. Now, when I call equals equals, like this, like on line 4 in that second block, when I say when I invoke the operator equals equals to check equality, Python will go and indirectly go look for the equals method, the EQ method in the class right here. All right? And let's just change it a little bit. Well, now it's false because the radiuses are not the same. They're in the same location, but their radiuses aren't the same. Maybe we just really do care about the radiuses being the same. I don't care where they are. Well, here this should still be false. But if they have the same radius, oh, I didn't rerun the block. There we go. There. Now, with this way I wrote it is, if the radiuses are the same, they're equal. I don't care about the x, y, z, and that's entirely fine. All right? So we now get to define it. If you wanted, you can say, like, return other, if other dot x plus 2 equals 4 or equals 5. Yeah, you could do that, and that would be valid logically, but it makes no goddamn sense. Right? Now I'm saying two spheres are equal if the other sphere's x plus 2 is equal to 5. Well, of course, that's a ridiculous thing, and it makes no sense for checking equality on things. But really, all that matters is that the equal method returns a Boolean, true or false. So, I mean, this is absurd, and it makes no sense, but it's valid. Yeah?
Does it even need to return a Boolean?
So in Python, no, but yes. Okay? Yeah.
So, like, as opposed to not using the magic method for equalities before, if we just put equal, it's just checking to see if the, like, attributes are all the same?
Nope. The default, it's the aliasness. It checks the sameness. If I have two references to the same sphere, it's equal. Otherwise, they could be equal in every way possible. But if they're not literally the same object, the default behavior of equals is sameness only.
But now when we compare two instances of the object with the equals operator, it runs through the equality definition of there?
Yeah, like that one there now. So we overrode, we override the one that we got for free that we didn't see. The one we got for free checks sameness. Now we say, okay, no, I don't care about sameness. This is what I actually care about. This is what it means for them to be equal. You have a question? It's very, this is critically important for you to understand before I move forward. So if you have a question, please, God, ask now. Should it matter? Should that matter? Well, I hope not. See, it's false. Oh, hold on. Let's make sure we actually ran this. It's false because they're in the different locations. Let's put them back. True. Yeah, cool. All right. There was something else here I wanted to show you. If you ever find yourself doing something like this, stop it. Don't do this. Don't do this. This is bad. You might say, but you can. Don't, though. You're breaking the rule. This is bad. Don't invoke these methods directly. You do it through what makes with the equals. Right? So this, bad. And in spite of me saying this, there's going to be at least 2 of you on the test that's going to do it like this, and it's going to drive me insane. Not you. Those that do it probably aren't here today. Okay. Questions? Yes?
Would you mark them wrong for heresy, or is it?
I would mark them wrong because it's I don't play that game of like, well, technically it's correct. No. You could be correct, but you can be wrong. And you're wrong. Yeah. I don't care about that. Technically it worked. No. You did it wrong. Yeah.
Could you go over the difference again between the
So the difference really is just, and don't overthink this one. When I call this, it actually goes and calls this. Python goes and goes, when they call equals equals, I really call this method. So this is like the indirect way to call that. Like watch this. If you don't believe me, watch. Oh. There. See, like I never called dot underscore underscore EQ underscore underscore directly. But when I call the operator equals equals, the comparison operator, it goes and it automatically runs the equals one, the EQ. Did that clarify it? So the default behavior though, if I don't write, watch. Let's get rid of this. I'm going to restart the runtime. Restart session. Yes. Oops. I'm going to run this. And I'm going to hit run on this cell now. But notice, when I ran this, I did not define the EQ method. If I don't define it, Python goes and adds one in there for me, whether I like it or not. And the one it goes and adds in there for me is the default behavior, which is sameness. Checks if we have two aliases to the exact same object. And I'm going to demonstrate this in a moment. But do we agree that based on how we did have the equals method defined, how we did have it defined, sphere A and B would be equal. Their x, y, z coordinates are the same and the radiuses are the same. And yet, when I go and call this, it's going to say, it better say, false. But they're the same in every way, yes. But we never told Python what it means for circles to be equal. And when you don't do that, Python goes, I only care if they're literally the same object. And let me show you. If I go down here and say C equals A, effectively creating an alias, C and A reference the exact same object, well, now this would be true, because C and A are literally pointing at the same object. So the underscore underscore, if we don't write it, it puts one in there for free. When we do write it, we override it. So I'm gonna run it now. Now if we go back to B, it'll be true. Well, yeah, it'll be true. When I call this, Python goes and Python says, well, really, they're calling like this. Like Python calls that. We never write that though. That is horrible syntax, and we're like eliminating the whole point of this feature of the language by doing this. This is terrible. It's syntactic sugar. Let's put it that way. Writing equals equals is nice syntax for checking equality, because that's how we've been checking equality for everything. The thing on the right, that's ugly and gross. So when we say equals equals, it goes, like, don't overthink this. When I say equals equals, it runs this method. Even though we don't directly invoke it, when I write equals equals, it runs this method. Happy, sad? Cool. Now, if you're worried about sameness, well, what if I really will still want to check sameness? Well, look, I mean, they're still, if they're literally the same thing, their x, y, z's are going to be, equal anyways, right? So you're safe. Other questions about this? Did that answer it? It can be a little funny, but I think people overthink it again. where calling equals equals, like on line 5 in the second box, goes and indirectly calls underscore underscore EQ. We never invoke the magic methods directly. We do them in some indirect way with some nicer syntax. That's all. Another magic method. All right, yeah, okay. Let me just finish this. The above code showing the EQ method is how we define our equals magic method. We'll check if all the attributes are the same. This is fairly typical. This is a very common pattern. Okay, you may be tempted to then check equality by calling EQ method explicitly. Don't do that. It will work. It's chunky and very bad style. You invoke it indirectly with using the equality operator that we're used to, equals equals. But we actually have a big problem with the way we wrote our EQ method. A really big problem. What would happen is a sphere, look, that sphere and that circle, are they equal? No, one's a sphere, one's a circle. I guess I could define what it, like, to check equality between these things, but I mean, they're not equal, right? So this should return false, right? But the problem is, it won't. It's going to crash. It'll crash because it'll try to say, like, well, some circle, what's your x coordinate? And it's going to go, I don't have an x coordinate. The circle only had the radius. So it's going to say, it'll crash, and that's a problem. So what we can do is just add a little bit. Yeah, it'll say, okay, circle object has no attribute x. Yeah, circle. Yeah, so the sphere class assumes that the other thing is a sphere. And if it's a sphere, I can get the spheres x, y, z, and radius because all spheres have an x, y, z, and radius attribute as per its definition. But the circle didn't, so we got a problem. Fortunately, there's a very easy fix for this because we don't want this program to crash. We want it to say false. They're not equal. So all we have to do is add this little special thing. I mean, there are a couple of ways we could do it, but here's a simple way to do it. Like, let me show you what I mean. Does A equal hello? Well, no. A string, I mean, I can't compare a sphere and a string. I can't do that. It crashes. But I don't want the program to crash. I want it to tell me, hey, are these two things equal? It should be false. Okay? Yeah?
So if your equals magic method for sphere compared only the x, y, and z, does that mean you could check its equality with, say, like a tuple that has an x, y?
You could make another object that had an x, y, z attribute, and it could be tricked into working correctly. I mean, that's a bad thing, though. You definitely don't want that to happen. So what we do to hedge against these situations is you go and you say, okay, look, there are a couple of ways we can do it. Oops. If other, we have this special operator, or this special function here, isInstance. It returns a true or a false. It takes a reference to an object and a type, and it tells you if that thing is in fact a thing of that type. So if other is a sphere, do the comparison. If other is not a sphere, return false. Easy peasy. We could do it the other way where you check, is it not a sphere? Return false. Otherwise, do the whatever. You can do it however you want, but this is an easy way to do it. So when I hit run here, and I hit run here, well, now I'm fine because it says, hey, is the string hello a sphere? No? Well, then it's not equal. It can start to get complex in your program where you're like, okay, I have a sphere, and then I have another type that's like a three-dimensional object. And a three-dimensional object is a sphere. So we might want to be able to compare these things and have it return true. It could get quite hairy, but we're not going to be doing anything like that right now. So it's fine. So you can get, there's a lot of flexibility with how we define this. Yeah? It's a function. It's a function that exists in Python that it lets you use, kind of like print. It takes a reference to an object and a type and gives you a Boolean telling you whether or not it is of that type or not. It's the first time we're seeing it. So if other is a sphere, we can do, okay, self.x.other.x, yada, 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 do the comparison. If it's not, just say false. They're not equal. For our needs, that's perfect. So now I can actually compare, hey, is A equal to hello? Well, instead of crashing, it says false. Questions, thoughts, concerns, comments, anything? And in reality, I should go back. If I were to go add an equality for a circle, this is what it would look like. Here's my circle's equality. Instance, other circle, return the comparison of the radius values, otherwise return false. Now imagine, consider the fact that this hello, here's a quiz for you. Hello is something of type string. Based on what you've seen, do you think it's entirely reasonable? No, I'm going to make a circle class real quick, right below the sphere class. I'm going to skip all the extra methods. I'm just going to write the equals method. So def return radius okay, I just wrote a very simple circle class. Okay, so I've defined a sphere class and a circle class. Any questions about what I just did? I wrote the initializer for the circle class. I also have the initializer for the sphere class. Sure, they have the same name, but they're in their own classes, so they are entirely separate. It's an init for the circle class, init for the sphere class. Same thing with the EQ. I've got an EQ method written here, but that's the EQ for the circle method we're looking at. Sorry, for the circle class. Here's the EQ for the sphere class, right? So I have two EQ methods written here, but one's the equality for a sphere and the other's the equality definition for a circle, and that's entirely fine. Now, okay. This is obviously false. Is the sphere A equal to the circle B? No. Why? Well, one's a goddamn sphere and the other one's a circle. They're not the same. So there we go. Fine. When I called this, though, so I got back false, which EQ method got ran? Why? Because it's first. You know what? Let's test that hypothesis. There, that's a little better. Looks like it. So, even though I have two EQ methods, because just as a nature of how I was calling this, A equals B, A is the self. So when I ask a sphere, hey, are you equal to something? Which again, I'm indirectly invoking underscore underscore EQ underscore underscore. I am calling that indirectly. I'm asking a sphere if it's equal to something. So I'm invoking the sphere's equality. To convince ourselves that it goes the other way too, well, let's switch the order. I'm asking now a circle, hey, circle, based on how you have equality defined, are you equal to that sphere? And well, it's going to say false. But we could see that it prints this string, which was in the circle's equality. So I have two equalities, and based on the order in which I ran things, it actually impacted which equality I ran. Yeah? We could, if we wanted to, we could do it like that. We could. I don't know if it's a good idea, but we could. The point is, I now have two equals methods, and the one that gets run, well, it depends on, did you ask a sphere if it was equal to something, or did you ask a circle if it was equal to something? That's all. All right. The next one we're going to talk about is repr. Underscore, underscore, R-E-P-R, underscore, underscore. How many times have you been writing code and you just wanted to, you've got a list, you just print out the list. Show me the content of the list just for the sake of debugging purposes? Of course you have, right? But you figure a list is actually a sophisticated data structure. When you printed it out, how did Python know how to print out the list nicely? Well, someone had to tell it. Someone wrote the code to say what it, okay, when someone wants to print out a list, this is what you look like. So, okay. If I were to print out a sphere, though, I would get something like this, right? Sphere object at OX, blah, 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 blah. A bunch of gibberish, right? And that's great and all. And the reason we get that is, just like that EQ method, that if you don't write the EQ magic method, Python goes and adds its own for you for free. You don't see it, but it adds it there. Same thing with repr. If you don't write your own repr method, Python goes and it writes one for you. And the one it writes for you is print out the name of the object and its memory address, where it exists, its hash. Maybe that's helpful for what you need, or maybe it's not. Often it's not. So we go and we override the one we get for free to say, okay, when someone wants to print out this sphere object, here's what I want you to do. And we can make it look like whatever we want. It's up to us. So what do I have here? Okay, repr, Okay, to address it, we write another magic method, repr. It's a representation function, which is for getting a nice string representation of the instance of the class. The repr method is called whenever we need a string representation of our object. So if we print it out, we want to get a string of something, or you can call repr directly. You can get the string version of the object. Listen carefully. This method, repr, does not print anything out. It does not print out anything out, and if your repr has a print in it, you're going to make me mad. It returns a string that you could do whatever you want with later. So repr returns a string representation of that object. If you were to go and look at the list class, you will find a repr. And you will find that the repr for that class is well, it would print something out in the form of, or print, it would return a string of the form like that. Usually, for simple classes like this, we have a common pattern for what our reprs look like. Name of the class, parentheses, all of the attributes. All of the current values of the attributes. That is a common pattern. This is an F string. What we're seeing here, and by the way, sometimes you'll see x equals, y equals, sometimes you won't. Sometimes it looks just something like this. right? Whatever. Sometimes it'll have the labels. But this will return a string representation of this specific sphere instance. You might say, well, the lists didn't look like that. The list was like square bracket followed by all the values. Well, yeah, that kind of made sense because it's a linear collection. And if you have a better idea of how you want to represent a sphere, by all means, have at it. But for our needs, it just needs to like display the data about that specific instance. So we'll just say the name of the class followed by its attributes. So now, if I run this, and here, let's go add one for the circle class. There. Oh, what did I do wrong here? There. Now, when I go down here, I've got a sphere, and I say print. Now remember before, when I did this, it would just say sphere at memory address OX blah, 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 blah. Now when I do it, it'll say, well, it's a sphere where X was 1, Y is 2, Z is 3, and radius is 4. And how was I supposed, well, that's just, it's 1, 2, 3, 4, there, then that's it. Cool. So that's what we would do. Now, you don't need it to look like this. You can make it look like whatever you want. You could be like, whatever. And when I hit run, okay, well, that's the string representation of a sphere. Not very helpful, but yeah, there we go. Maybe you want it to look something like, I don't know, you want to say, maybe it should look something like this. Maybe, no. Plus times self dot radius plus, I don't know, something like that. So like if it's a bigger sphere, if we make it like 40, let's make it 14. It's bigger, right? Maybe that's what we want it to represent. Oh, it's like a bigger sphere. I don't know, whatever. We can make it look whatever we want. But if you don't have something very specific in mind in terms of like what it should look like for your needs, follow this basic pattern of name of the class, attribute, 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 etc., etc., etc. So that's how we would do it. So now, if I'm ever like, what the hell was that sphere? What was that sphere again? What did it look like? Oh, it's oh yeah, right, yeah. So now we actually have a more useful string representation for our object here, which is nice. Questions about this? Now notice I didn't call repr directly. In fact, really, like I could do this. This would be bad. Don't do that. This is bad. You would just like do this. Now, this is an example of Python doing a little bit of extra stuff here for you. Whenever you print something out, Python's going to immediately try to convert that thing that you're printing out to a string, and then print out the string representation of that thing. So it's kind of like if I wrote this, stir of A, okay? It's kind of like I wrote that, but I didn't need to write stir of A to print out A. This will work just fine. I didn't need to do that. Because print will automatically try to convert the thing, like print will only print out like strings. So it's going to try to convert everything you have to a string. All the numbers that you've ever printed out were actually strings. Why? Because that's what Python does. It doesn't have any functional effect for us. It's just, that's what it's doing. So really, the way we would call repr is by saying like stir of A. Instead of saying like A dot underscore underscore repr underscore underscore. Now, technically there is a difference between repr and stir. they have a slight difference, we're not going to worry about it. It doesn't matter. I can't even remember which one's which anymore. Most people, you just use repr. Cool. Yeah. Yeah, this works just fine, but if I saw that in someone's code, I'd be like, you would just do this. Because this print will automatically turn it to a string for you by calling like that string function. Other questions or anything? Yeah. Well, I actually meant him first. I'm sorry. I'm just saying.
So you don't go to jail for that one.
You won't go to jail, but I will have judgment. I will stir in my seat. Yeah. Yeah.
How does like backslash and stuff work in repr?
Yeah. Yep. If you wanted, you could, because it just returns the string. So I can be like /n. Why? Because. Should I have done this? Probably not, but I can. Yeah. Because at the end of the day, it's just returning the string. That's all we're doing. And here, let's show you, let's print out the circle. Well, here, let's rerun this to show you it's normal. What happens when we print out the circle? Circle. Radius is 5. Perfect. Cool. So why did one print out the circle string and one print out the sphere string? Well, because A was a sphere. So when I wanted to print out the string representation of the thing that A referenced, well, the thing A referenced was a sphere, so it called the spheres. Similarly for the circle. I asked the circle, give me your string representation. So it went and looked up what its string representation function was. Yeah. Now, if I were to start writing tests for all this, it's going to get a little hairy. Because I want to test this class, and this is valid. But I mean, I don't know, this is getting kind of hairy, right? Because first of all, I have to like create the instance, and then I call all of the attributes, all of the methods, check equality, check. It's starting to get hard to keep track of all this stuff. This is fine, but it's, it's getting kind of hairy. Anyways, we'll stop there for now.